Hey everyone, buckle up because today we're going to try to wrap our heads around something pretty wild. Extra dimensions.
It really makes you wonder if what we see is just the tip of the iceberg when it comes to reality.
Right, like what's going on behind the scenes that we're just totally missing. And to navigate this crazy cosmic maze, we're taking cues from physicist and cosmologist Dan Hooper. He's got some seriously thought-provoking ideas.
He's not afraid to ask the big questions, that's for sure.
So how do we even start to think about extra dimensions? It's not like we can just, see them.
Well, imagine you're an ant on a piece of paper. That 2D surface, that's your whole world. You can go forward, back, left, right.
Okay, I'm picturing it.
But up and down, totally alien concepts to that ant. Our universe could be like that giant sheet of paper, and we're just clueless about the dimensions beyond it.
Whoa, okay, so that kind of makes sense. But how do physicists actually study something they can't even see or touch?
Well, they look for the cracks in our current understanding. The little hints that something's not quite adding up. Gravity, for instance. It's weirdly weaker than all the other fundamental forces. Think about it, a tiny fridge magnet.
Yeah.
It can defy gravity's pull so easily, even though it's tiny.
True. A fridge magnet is surprisingly strong.
Right. Gravity holds us to the planet, but it seems kind of pathetic compared to those magnets. That weakness could mean its force is leaking into those extra dimensions, like spreading out and getting diluted.
So gravity isn't actually weak, it's just spread out over more dimensions than we can perceive.
Exactly. It's like a sound being played on multiple speakers. You only hear it clearly from one because the others are spread out.
Wow, okay. So our perception of gravity is just a fraction of its true power. My mind is a little blown right now.
It is a pretty wild idea. And one of the earliest attempts to tackle these hidden dimensions was the Kaluza-Klein theory back in the 1920s.
Wait, 1920s? They were already thinking about this stuff way back then.
Oh, yeah. They were ahead of their time, for sure.
So what was their big idea?
Well, they thought there might be a fifth dimension, but curled up so small we just can't see it. And this hidden dimension. They thought it held the key to uniting gravity and electromagnetism, kind of like a single, elegant equation that explains two completely different things.
So they were looking for a theory to connect those fundamental forces, the forces that literally shape our universe.
You got it. Now, it didn't pan out exactly how they hoped. Those equations got kind of messy.
Science is messy sometimes, right?
Right. Definitely. But it paved the way for a lot of what we're exploring now. Even partially true theories can shake things up and get everyone thinking in new ways.
That's so cool. So we've got these hints of extra dimensions, but how do we actually find them?
Well, what if I told you there might be a tiny particle out there, a particle called a graviton, that holds the key to unlocking those extra dimensions?
We're back. Last time we were talking about this graviton, this super tiny particle that could hold the answers to all these huge cosmic questions.
Yeah, think of the graviton like a little messenger particle. So like photons carry light.
Right.
Gravitons, they'd be the ones carrying the force of gravity. But here's the wild part. Gravitons might be the only particles that can actually travel through these extra dimensions. Like they have some kind of special pass.
Whoa, hold on. So they get to go backstage while all the other particles are stuck out here.
Exactly. And that's what might be making gravity seem so weak to us, compared to the other forces.
Because it's spreading out into those dimensions we can't see.
Yeah, exactly. It's like if you're listening to a radio station, but it's broadcasting on multiple frequencies at once, you're only going to pick up part of the signal because it's stretched out. You know what I mean?
Okay, I'm following you. So gravity isn't actually weak. We're just experiencing like a watered down version of it.
Yeah, exactly.
Okay, so if these gravitons are zipping in and out of other dimensions, how could we even prove that? How do we even test that idea?
Well, there are some really mind-blowing experiments being designed right now. They're trying to see if gravity changes even a tiny bit over very small distances, like crazy small distances.
Oh, wow. And if it does,
that could be a sign those gravitons are interacting with those hidden dimensions. We're talking about potentially rewriting our understanding of physics. This could be huge.
That's insane. And you mentioned earlier that these gravitons could also help us understand the mass of particles. How does that work?
Okay, so imagine you're watching a puppet show, right?
Okay, I'm with you.
The puppets seem like they're moving on their own, but there are these strings controlling them that you can't see.
Right.
What if those strings are actually gravitons interacting with those hidden dimensions?
Okay.
And those interactions, that's what gives particles their mass, even though the gravitons themselves might not have any mass. It's wild.
So mass, what we think of as mass, is like a side effect of these gravitons we can't even see. Okay, my brain is officially starting to hurt.
Laughs lightly. It's a lot to take in.
It is. So how does this fit in with everything else we know about the universe, like the Big Bang, dark matter, all that stuff?
Right, so that brings us to the standard model of cosmology. It's basically the best explanation we have right now for how the universe works.
Right.
But it has some pretty big holes. Like, it doesn't fully explain things like dark matter or dark energy.
And those make up a huge chunk of the universe. It's like we're missing pieces of a giant puzzle.
Exactly. And Dan Hooper, he's suggesting that those missing pieces, those could be those extra dimensions and the way gravitons interact with them.
So we might have to rethink literally everything, like from the smallest particles to the structure of the entire universe.
Yeah.
And it all comes back to these gravitons. Wow. Okay. And as if that wasn't crazy enough, what if those gravitons aren't even stable? Like, what if they could decay?
Right. What if these gravitons, they can actually transform into other particles that we do know about, like photons or electrons?
So before the break, we were talking about graviton decay, which is like already blowing my mind.
Yeah.
Are we saying these gravitons, the things that might explain like the entire universe, could just disappear?
Well, not disappear entirely, but they might transform. They could decay into other particles, like the ones we're more familiar with, photons, electrons.
Hmm.
It's still a theory, but
Okay, so the thing responsible for, like, holding galaxies together could just decide to become something else. How is that even possible?
it's a huge question. And it could bridge the gap between two of the biggest ideas in physics, general relativity and quantum mechanics.
Right, because right now those two don't really get along, do they?
Not really. They each work great on their own, but trying to combine them, it's a mess. But graviton decay, that could be the missing link, the thing that finally shows us how gravity works at the tiniest level, the quantum level.
Okay, so it's like finding the missing piece that lets you finally put those two giant puzzles together.
Yeah.
And didn't you say this could also tell us something about dark matter and dark energy?
Oh,
Those are still huge mysteries.
totally. We can't even see dark matter or dark energy directly. They don't interact with light the way we're used to. But what if? What if they're not made of something totally new? What if they're actually byproducts of graviton decay?
Whoa. So, like, gravitons decay, but they leave these little traces behind, these footprints that we perceive as dark matter and dark energy.
Exactly. It's like a ghost. You might not see it, but you can see its footprints, the way it interacts with the world. And these footprints, they could change everything about how we understand what the universe is made of.
My mind is officially blown. We started with extra dimensions, and now we're talking about rewriting our entire understanding of, like, reality itself.
And the craziest part, we're just getting started. If gravitons really are decaying all around us, think of all the subtle signs we might be able to pick up. Gravitational waves, for example, those ripples in space-time. Those could hold clues.
It's like searching for a tiny whisper in the middle of a roaring concert.
Exactly. But that's what makes science so amazing. Every answer just leads to more questions, more things to explore, and who knows what incredible things we'll discover along the way.
Well, I am definitely hooked. And if any of our listeners want to dive even deeper into this, I highly recommend checking out Dan Hooper's work. He's got some incredible stuff out there.
Absolutely. He's a great guide to this mind-blowing stuff.
Thanks for joining us on this wild ride, everyone. Until next time, keep looking up and keep those questions coming.